In today's lecture, we will be continuing with the concept of virtual work. In the last class, we studied about the steps that we have to take, which will help in solving the problems for virtual work. Steps for solving problems of virtual work. So it's a 6-step methodology that we took to solve this problem. Now today, before continuing with the further more complicated examples, I would like to take up some basic conceptual concepts that you have studied in your school days. And these concepts are going to come in handy in solving your problems of virtual work. So, the first concept that I want you to understand, or rather, I want you to recall from your school days, is the concept of similar triangles. Let us say that we have a triangle of any shape and size. It need not be an isosceles triangle. What I have drawn here, maybe it looks like an isosceles triangle, but it necessarily it's there is no need for it to be any type or typical sort of triangle. It can be any random triangle. Okay. So I have taken one triangle, and now what I do is that I draw a line parallel to the base inside the triangle. And now let me name these triangle vertices as A, B, C, D, and E. Okay. The important thing is that BE is parallel to CD. And now the concept of similar triangles says that triangle ABE is similar to triangle ACD. That means this smaller triangle is similar to this larger triangle containing it. And how do they become similar to each other? Since this line is parallel to this line, it automatically implies that this angle is equal to this angle and this angle is equal to this angle. And that is the only requirement for any two triangles to be similar to each other. That if any two of the consecutive or corresponding angles of the two different triangles are same, then those triangles must be similar. Now you have learned the concept of congruent triangles also. But there is a very essential difference between congruent triangles and similar triangles. If a triangle is congruent to another triangle, that simply means that those two triangles are exactly the same. They have the same size, they have the same angles, and if one triangle is placed over the other triangle, you won't be able to see two triangles. You will see exactly one triangle only. So congruent triangles means they are exactly the same. Similar triangles means they look similar, but they need not be congruent to each other. So if I take these two triangles separately, I can separate the smaller triangle, triangle ABE here, and I can separately put the larger triangle, triangle ACD here. Now these two triangles are similar, not congruent. By similarity, we know that the angles or the corresponding angles of these two triangles will be same. But the most important mathematical outcome of comparing two similar triangles is the proportionality of their sides. Now that is what you have to remember regarding similar triangles. So let me take this same triangle, triangle ABE and triangle ACD. We already know that these two triangles are similar because two of their angles are same. And if two of their angles are same, by default, there is no need to further explain that the third angle will also be the same. Because the third angle is simply 180 minus the sum of the other two sides, sorry, other two angles. And since this angle and this angle are same for the triangles, so the third angle must automatically be the same. But the essential requirement stops at only two angles being the same for two triangles, so that they can be called as similar triangles. Now, what is the law of proportionality that goes in triangle ABE and triangle ACD? So if two triangles are similar as shown in the figure, then you can write the following proportionality relationship. I am simply presenting the relationship without explaining the mathematical proof. The proof part you can simply go and take it from any ninth class or 10th class mathematics textbook. So we will not be discussing that. We will be simply recalling and remembering the relationships, because these relationships are going to be important for us to develop the equations of virtual work. So let us see what is the proportionality relationship of similar triangles. I can write that since triangle ABE is similar to triangle ACD, therefore AB divided by AC must be equal to AE divided by AB. It's easy to remember. Take one side of the smaller triangle AB. The corresponding side of the larger triangle is AC. Take the ratio of these two. Take any other side of the smaller triangle again. So let us say AE. And the corresponding larger side of the other triangle is AD. Take the ratio of these two. And I can even write that these two ratios are also in turn equal to the ratio of BE by CD. That is the ratio of these two corresponding sides. So this relationship, or rather this ratio relationship, that AB by AC will be equal to AE by AD will be equal to BE by CD. So as you can see that there are two triangles, one smaller and one larger triangle. If they are similar to each other, then the ratio of their corresponding sides will always be found equal to each other. Okay? By the extension of this same logic, now let me say, I will draw another triangle. And this time, let me draw the line parallel to the vertical side. Okay, so this is a new triangle A, B, C, D, E. Let us say this is 90 degree. So if this is 90 and this is 90, there is no need to explain that line AB is parallel to line CD. And since these lines are parallel, therefore we automatically have this angle equal to this angle. And this angle is common for both the triangles. So we can say that triangle CDE is similar to triangle ABE. Now, since these two are similar, I automatically have this kind of relationship. So this kind of relationship, or the ratio of sides, you can automatically develop for this triangle also. But now I want to develop some other relationship. Let us see what other relationship can be derived from this. Now look at the relationship that I am writing very carefully. I am claiming that since CDE is similar to ABE, then the side CE, or rather I should say the line segment CE divided by AC will also be equal to the ratio of the other sides. That means DE by BD. Now please note here that CE and DE are actually sides of triangles. See, CE is one side of the smaller triangle. DE is one side of the smaller triangle again. But AC is not a side of any triangle. See, this is only a line segment starting from here and ending here. So it is not a complete side of the triangle ABE. This is not a complete side of the triangle CDE. So AC is not a part and parcel of any complete side. And similarly, if you look at BD, BD is also an incomplete line. This is not a complete side of either of the two triangles CDE or ABE. But still, this ratio holds true. There is a mathematical proof for this also. This is called as the law of proportionality of the sides of a triangle cut by two parallel lines. So this law simply states that if there are two parallel lines and if they constitute a triangular structure, then the ratio of these two line segments will also be same. That means this side divided by this side must be equal to the ratio of this side divided by this side. This happens only in the case of similar triangles. So now we have refreshed some basic ideas regarding similar triangles. And now let us go back to a problem of virtual work and see whether we can apply the concept of similar triangles in our convenient usage. Now I will come to this problem. This problem says a uniform bar of mass m. Look at this figure. This is the uniform bar. It's a rod. Okay. This rod is resting on a vertical wall. This is a vertical wall and this is the ground. And what are these? These are rollers. Okay. So we have a rod which contains rollers at both the ends. And it is simply supported on the wall. Now there is another thing that these people have done. What have they done? If you simply put a rod, I mean, if you take a corner of the wall, this is the point of meeting of the ground and the vertical wall. And if you put a roller supported rod by resting it like this, do you think that it will stay in this position? No. It will roll down and eventually it will fall down to the ground. This cannot hold its position on its own. So in order to keep it in position, what these people have done is they put a small support on the wall here. They put a small support on the rod here. And then they connected this rod with the wall with the help of a thread. एक धागे से इसको यहाँ पे बांध के पकड़ लिया. And now you see that due to the weight of the rod, it had a tendency to fall down to the ground like this. But if you tie it at any point with the help of a thread, then the tension in the thread will not allow the rod to fall down. So the rod will try to fall down, but this thread will become tight and it will prevent the rod from falling. And eventually you get what is called as an equilibrium. That means if a thread is connected like this, then your rod will be held in equilibrium in its position. So it will neither be moving down nor will it be climbing upwards. It will be simply holding its position as shown in the figure. So somebody please put on your microphone and tell me whether you have understood the configuration of the problem. ये problem दिखती कैसी है और चीज क्या है ये समझ में आई क्या आपको? Somebody please put on the microphone. Anybody?
Yes, sir.
चेतन समझ में आ गया आपको?
Yes, sir.
Okay. Now, the question is, if this rod is held in equilibrium in its position by connecting it with a thread and slanting it onto a wall and a ground like this, then you have to find what is the tension T in the thread. Obviously, this thread is preventing the fall of the rod. So there must be a tension, a force of tension which is holding the rod in its place. And the question is, use the concept of virtual work to find the value of this tension in the thread. Okay. So now what we will do is we are going to apply the concepts and the steps of virtual work that we learned in the previous class, and we are going to apply in this problem to find the value of tension T. Okay, so let us go back to the steps here. So we will be coming back and revisiting this page so that we can take the steps one by one. The first step is draw the active force diagram of the system. Okay. Now let us draw the active force diagram of your ladder. And let me once again remind you what is the meaning of active force diagram and how is it different from a free body diagram. A free body diagram will show you all the forces and all the reactions acting on the body. However, an active force diagram will show you only the active forces acting in your system. And what are active forces? Active forces are those forces which are capable of producing virtual work because of impending motion. So that means those force points which are capable of moving in space and thereby by virtue of motion they are capable of creating work. They are called as active forces. So if you ask me what will be the active force diagram of the system, I will draw the wall, I will draw the ground, and to simplify my figure, I am simply hatching the lines like this so that the wall and the ground are clear. And now what I will do is I will draw a small roller here, slant it, another small roller here. The only information that is given to us is with the help of this image. So let us take down the information from the image. Now see, a random angle of theta is being subtended by the inclination of the rod. So what is this angle theta? I don't know. I will simply write it as theta. Okay. Where is the thread tied? The thread is connected on the rod at such a point so that if the complete length of the rod is L, then the connecting point of the thread is dividing this rod into two parts such that the bottom part is L by 3 and the top part is 2L by 3. So this geometric information is also known to us. So we will take this information also into account. And see, this is the active force diagram. So now what I'm going to do is I will simply put a dot here to indicate the position where the active tension is acting. So this tensile force T is acting in the left direction. This is an active force. Now, I would just like to bring your attention to these points also. There is obviously a reaction that will be developed here, and there will obviously be a reaction that will be developed here. But since the wall cannot move, and since the floor cannot move, therefore, this reaction of the wall and this reaction of the floor cannot produce virtual works. And that is the reason why this reaction F and this reaction W of the wall will not be considered in the active force diagram. If somehow this same problem was asked to you and you were asked to create the free body diagram, in that case, this RF and RW will appear because that is a free body diagram. But in the case of an active force diagram, only those forces have to be drawn which in some way or other can produce some work. So I will take away these two forces. No reaction on the floor and no reaction on the wall. Only active forces. So I have drawn this tension T, and there is another active force. Please refer to the question again. This says a uniform bar of mass M. So if this bar has some mass M, then definitely from the center of gravity or the center of mass of the rod, a gravitational force mg will act downwards. So I will draw this force also, and I will explain why mg and t are active forces. So what I'll do is I'll take the center of the rod. This point is the center of the rod, and I will draw another force which is equal to mg. Mg is acting downwards. Now, these are the only two active forces in the problem. Why are these two active forces? Eventually, to make use of the concept of virtual work, what you have to do is you have to give this ladder some small virtual displacement. And how do you do that? If the ladder is originally positioned in this angle, then you will either tilt the ladder so that it becomes and comes into a new inclination like this, or you can incline it like this. So basically what you are going to do is change the inclination of the rod that is kept like this. So either you move this leg towards the wall, or you move this leg away from the wall. By this way, you will be able to change the value of this theta by a small amount. And while you are doing so, please look at this figure. This point will move slightly upwards if you move this inwards. And eventually this point will move slightly towards the left also when you move the wheel towards the wall. And look at this point. When you move the wheel towards the wall a little bit, then this point will move upwards, and this point will move towards the left also. Or in other words, both these points will slightly move upwards and slightly move leftwards. And since these 2 points are capable of changing their position and moving a little, therefore, the forces acting at these points will be capable of producing work. And that is why mg and t are active forces. So if you ask what is the active force diagram for this problem, which happens to be our step number 1. Step number 1 for our problem is draw the active force diagram of the system. And this is the active force diagram. Which one? Not this. This is the active force diagram. Now, let us go to the next step. Select a stationary point like top, bottom, or corner of some fixed wall in the diagram as origin. In other words, this complete step can be simply written as select a suitable fixed origin point in your figure. So let us come back to the figure. Which is the ideal point to be selected as origin in this figure? Can somebody put on the mic and tell me which point in this figure do you think is the best one to be selected as the origin? Anybody? कौन से पॉइंट को ओरिजिन लेना चाहिए अपने को? Nobody? Fine. This is the best ideal position for selection of origin. Now, let us move on to the third step. The third step says mark distances x1, x2, x3, etc. from origin to all points showing horizontal forces. So let us first see which are the horizontal forces. How many forces are there in total? There are only two forces. One is the tension and another is the weight, mg. And out of these two, only one is horizontal, and that is tension. So this step says if there are n number of horizontal forces, Mark x1, x2, x3, xn as the distances from origin of all the horizontal forces. So what I will do is, since there is only one horizontal force, I will take a construction line here and I will mark this distance from origin to the point of the application of force and mark it as x. I don't have to use x1, x2, etc. Why? Because there is only one horizontal force. If there were multiple horizontal forces, I would have easily put different x values for them. And similarly, I have to mark distances y, y1, y2, y3 from origin to all points showing vertical forces. And let us now see which is the vertical force here. There is only one force which is vertical, that is mg. So I will take the distance of point of application of mg from the origin and name that distance as y. Again, there is no need for me to use y1, y2 because there is only one vertical force. So this step is also completed. Marking of x and y from origin for horizontal and vertical forces. And now, coming to the fourth step, it says we don't want multiple variables like x, y, z in your problem. It's better to convert all the different variables in terms of one common variable, and that can be easily done with the help of this angle theta. So now the next step is establish relations between all x and y in terms of some common variable theta. So let us see how we are going to do that. Now I will do some geometric construction. First of all, I want to establish a relationship between x and theta, and then I will establish a relationship between y and theta. And by doing so, I will be eliminating x and y from my equations, and only theta will be remaining in my equation. So my numerical computation will become easier. So let us see how we can do it. This is the complete length of the rod. This distance is x. This is theta. Now, what I want is to develop a relationship between x and theta. Now, let me name these vertices as A, B, C, D, and E. Okay. Now, can I say that CE divided by AC must be equal to DE divided by BD? Why? Because triangle ABE is similar to triangle CDE. Since these two triangles are similar, what I can say is this length CE divided by AC must be equal to DE divided by BD. This relationship is already known to us. So by using this relationship, let me try to establish a relationship. What is CE? If you look in the original figure,
L by 3.
it is L by 3. So I will write CE as L by 3 divided by AC. What is this distance? This is 2L by 3. This is equal to DE upon BD. BD I know is X. BD is X. How do I get a value for DE? Okay, we can obtain that very easily. First of all, tell me, can anybody give me the value of BE? BE is this complete side. This is theta. This whole length
L
is L.
L cos theta.
Very good. BE is equal to L cos theta. If BE is L cos theta and BD is X, what is DE?
L
L
by 3 cos theta.
It is L cos theta minus X. Agreed? Now, what is this ratio? L by 3 divided by 2L by 3. This will be 1 by 2. So that means 1 by 2 is equal to L cos theta minus X divided by X. Now I will cross multiply and get a relationship. X is equal to 2L cos theta minus 2X. I will take this 2X to the other side. This will be 3X is equal to 2L cos theta. Or in other words, I can say X is equal to 2 by 3 L cos theta. This is the required relationship that I needed between theta and x. And in the similar fashion, I will have to develop a relationship for y and theta. Now, y is the vertical distance. Okay. So, what I will do is I will draw another image here. This is theta. Y is the distance from the origin to the point of application of mg force. See here. And as you know that mg for a straight rod will be located exactly at the center of the rod. So this distance must be L by 2 and this distance should also be L by 2. Why? Because this is the center of gravity of the rod and this is y. This vertical distance is y. Now again, we have two similar triangles. Now let us rename this vertices A, B, C, D, and let us say E. Now we have triangle ABE is similar to triangle ACD. And we have to develop a relationship between y and theta. So I can say that AB divided by BC must be equal to AE divided by ED. This is understood because these two triangles are similar to each other. Now, tell me what are the known things here. What is AE? AE is L by 2. So I can simply put it as L by 2. What is ED? ED is also L by 2. So what is the ratio AE upon ED? They are both same. So this is equal to 1. So I will take it further on. AB by BC is equal to 1. This is what I get. Now let me see. What is BC? BC is Y. So I can write as AB by Y equal to 1. Now what is AB? In order to get AB, what I will do is I will simply try to find what is AC. If this is theta, if this whole length is L, what is AC?
L sin theta.
It is simply L sine
L
theta.
sin theta.
So AC is equal to L sine theta. And now the question is, if this whole length is L sine theta, if this length is Y, what is this length?
L by 2.
L by 2 sin theta.
That should be L sine theta minus Y. See, AC is L sine theta. Okay. BC is Y. What is AB? It is L sine theta minus Y. So I can say that since AB is L sine theta minus Y, so my relationship becomes L sine theta minus Y divided by Y equal to 1. And now I will cross multiply. This will give me L sine theta minus Y equal to Y. Taking this minus Y to the other side, I will get L sine theta equal to 2Y, or Y is equal to L by 2 sine theta. This is the relationship between Y and theta. So this step is also complete. See, this is the first time you are dealing with such questions. So with all the explanation that I am doing, you might get a feeling that this is a very lengthy problem, but it is actually not. With enough practice of such questions, you will have an intuitive knowledge of doing all these computations that are taking a lot of time here. As soon as you see a problem of this type, you will automatically come to the conclusion, okay, I see a similar triangle here. See, this is a similar triangle. I see two similar triangles here. See, this one, small one, the big one. And you directly apply the relationships of a similar triangle. So with given practice and given time, you will be able to do this in less than 2 minutes. All these relationships. See, these two relationships, we had to take a lot of time to get to this point. Y is equal to L by 2 sine theta and X is equal to 2 by 3 L cos theta. These relationships took a little while. But with practice, you will be able to come to this conclusion very quickly. Now, this step is not completely over. What does this step say? Remember to correct the sign of the relation plus or minus by checking whether x and y increase or decrease with respect to theta, the common variable. So this has to be rechecked by us. Whether the relationships that you have constructed here. So x relationship is 2 by 3 L cos theta. Now what I want to know is, if I try to increase theta, so I am trying to increase the value of theta, what will happen to x? Please remember, x is this distance. This is x.
Decrease.
If theta is increased, x will decrease or increase?
Decrease.
Sir,
ये कम होगा, क्योंकि जैसे थीटा को बढ़ाने का मतलब है आई एम मूविंग द व्हील इनवर्ड्स. As the wheels are moved inwards, this theta will increase. Why? Because from this position, your rod will come into this position. This is increase of theta. See, initial theta was smaller, final theta is larger. But what has happened to the point that was here? This point has moved to this point. So you see, so that means if theta is increased, x will decrease. So this is a reciprocal relationship. You can do it the other way also. You try to move the wheel away from the original location. In that way, you will be decreasing the value of theta. And if theta is decreased, this point will try to move to this side. And by doing so, it will increase the value of x. So if theta is attempted to be decreased, then you will find that x will be automatically increased. So in any case, whether you increase theta or decrease theta, you will see that x is following a reverse relationship with theta. And therefore, whatever expression you have developed between x and theta is a negative relationship. So I will correct this relationship here and I will simply put a negative sign here. That is the correction that I need. So x is not 2 by 3 L cos theta, it is minus 2 by 3 L cos theta. So I have corrected the relationship for x. Now let us go back and find what happens if I try to increase or decrease theta to the value of y. See, this is the center point of the rod and this is where mg is acting. And this is the location at which I was measuring my y. This is origin and this is my y. So what will happen if I try to, let us say, increase the value of theta? I'm increasing theta or I'm moving this point inwards. So if this was the original inclination of your rod, now the final inclination of your rod is somewhat like this. I'm increasing theta. This was the initial theta, this is the final theta. What happens to a point that was at the middle of the rod? Will it move upward or downward?
Upward, sir.
It will move upward. So if this point is moving upward, y is obviously increasing. So that means if theta is attempted to be increased, then y will automatically increase. And by extending the same logic, you can take the reverse also. If you try to reduce theta, how do you reduce theta? By moving point B away from the wall. In that case, theta will get reduced. You will see that this point will also come down. So y will be reduced. So if you look at this relationship, you don't have to develop both these relationships. You can develop only one sort of relationship. Either you try to increase or you try to decrease. You will automatically get the type of relationship. So with theta decreasing, y decreases. With theta increasing, y increases. This type of relationship is a direct relationship. And direct relationships are positive relationships. So what I will say is that for this part, y is equal to L by 2 sine theta, I will keep it as positive only because theta and y have a direct relationship. So now I have corrected the sign of the relationships for x and theta and the relationship for y and theta. And now let us move on to the next step and see what it says. This is done. Take the derivative of all relations to get relations for all delta x and delta y. Or in other words, all that you have to do next is to find the derivative of these two expressions. So my first expression was, I will bring it down, x is equal to minus 2 by 3 L cos theta. So x is equal to minus 2 by 3 L cos theta. This is my x and theta relation. This is my y and theta relation. Now you have to take the derivative. Please do the differentiation for me and tell me what is delta x. This we had done yesterday also. So give me the relationship for delta x here.
2 by 3 L sin theta, del
This
theta,
will be 2 by 3, no
L
negative sign, L sine theta
del theta.
L theta. Very good. Correct differentiation. And now give me the derivative of this relationship and tell me what will be del y.
L by 2 cos theta del theta.
Very good. This will be L by 2 cos theta del theta. So I have achieved the values of del x, del y in terms of del theta. Now, what is the next step? Give the system an actual small virtual displacement. Now you actually try to move the system and see what is the virtual work created by all the forces. Then equate the sum of virtual works to 0. So what do we have to do? Let us come back to our system. This is your system. This is theta. This is tension. This is mg. And now this is the vertical location. This is the horizontal location. This is the origin. Now you give a small virtual displacement to the rod. How can we do that? You can choose either to move the base of the rod to the right side or to the left side. It is your choice. छोटा सा virtual displacement produce करना है, वो कैसे भी किया जा सकता है. ऐसा कोई कंपल्शन नहीं है कि पॉजिटिव डिस्प्लेसमेंट देना है, नेगेटिव डिस्प्लेसमेंट देना है. यू कैन डू इट अकॉर्डिंग टू योर विश. So let me draw a clearer image here. This is theta. Center of the rod at a distance of y. This point where the thread is tied and where the tension is acting, this is at a distance of x. And now what I am doing is I am slightly increasing this theta by del theta. Now just look at the figure and tell me, if I increase theta, what will be the motion of this point at which mg is being applied? Will it move upwards by delta y or downwards by delta y?
So upward with delta y.
So this point will move a little bit upwards by, let us say, delta y. Now delta y is upwards, mg is downwards. What is the work done by the force mg when it is moved upwards by delta y? Give me the value of virtual work of mg. Always remember, whether the work is
Minus mg
virtual or
del y.
not, work is always force into distance.
Minus mg del y.
Very good. The virtual work done by mg, or let us call it as delta u1, is equal to minus mg delta y. Why did you select the minus sign? Because the displacement is upwards and force is downwards. Even if it is reversed, it doesn't matter, because the force and the displacement are opposite to each other. Therefore, the product resulting as the work done must be put as negative work, because displacement and force are opposite to each other. Now, again, considering that a small increase in theta by del theta was given, what will happen to this point? Will it move to the right by delta x, or will it move to the left by delta x? I'm talking about this point now.
Left.
It will move towards the left. See, if theta is increased, that means I am moving this point towards the left. I am shifting the rod towards the left side from the bottom. That will increase theta. And in doing so, this point will be forced to move towards the left by a small value of delta x. Okay. So that means delta x has a direction towards the left. Now see, what is the force that is being moved by delta x? It is T. T is also towards the left. Delta x is also towards the left. So the virtual work done by the force T, let us call it as delta U2, will be T into delta x. Should I place a plus sign or minus sign for T delta x?
Plus.
It will be plus, because although tension is in the negative direction, delta x is also in the negative direction, but the work done by T and delta x will be positive, because both of them are in the same direction. So it does not matter whether the same direction is leftwards or rightwards. If the force and displacement are having the same direction, then the work is positive. No questions asked. So this is plus T delta x. And now by applying the principle of virtual work, we know that the total amount of virtual work for a system which is in equilibrium, that is delta U1 plus delta U2, must be equal to 0. This is the principle of virtual work. So I bring in these two expressions and put them together. I will say T into delta x minus mg into delta y must be equal to 0. Now let us bring in the values of delta x and delta y which we have developed here. Delta x is 2 by 3 L sine theta del theta. Okay. So T 2 by 3 L sin theta del theta minus mg. What is the value of del y? L by 2 cos theta del theta, and this is equal to 0. Now let us see. Now let us simplify this. From both these terms, L can be taken as common, so we will take it to the right hand side and divide it with 0, it will vanish. Del theta can be taken as common from both the sides, sorry, both the terms. Again, it will go below 0 and become merged with 0. So after simplifications, what I get is 2 by 3 sine theta into tension minus mg by 2 cos theta equal to 0. So I will take the negative quantity to the right hand side. 2 by 3 sine theta into tension is equal to mg cos theta by 2. Our objective was to find the value of tension T. What do I get? T is equal to 3 by 4 mg cot theta. Am I right? Is this correct or not?
Yes, sir.
Let us check the answer. 3 by 4 mg cot theta. So I hope that this problem was understood. There are a lot of variants of these problems in which a ladder is inclined on a wall and floor like this. Sometimes they give the value of friction here. Instead of tying a thread, they say that the rod is not falling down because there is friction. In that case, you have to bring in the concept of frictional force is equal to mu into vertical reaction R. In that case, you have to take the vertical reactions also. So that problem becomes a little bit more complicated. Sometimes they give the problem like this, that the wall and floor are frictionless and some unknown force is applied at the bottom to hold the ladder from falling down. This rod is prevented from falling down by applying a load of, say, unknown force, say Q, sorry, P. And they say that the rod itself has a weight of mg. So if you remove this constantly applied load P, the rod will fall down. So what is the value of this constant load P that you have to apply at the bottom of the ladder to prevent it from falling? The same thing can be reversed as another question. I can put the question like this. A frictionless wall is there, a frictionless floor is there, a frictionless rod is there. Or you can put rollers. If you do not want to say frictionless, you can simply put rollers here. It will automatically imply that this is almost frictionless. And now, with how much force applied in the vertical direction, let us say Q, how much force should I hold the top part of the ladder continuously so that the ladder does not fall down under the influence of its own weight? अपने खुद के भार से इसको गिरने से रोकने के लिए इस पॉइंट पे मैं कंटिन्यूअसली कितना अपवर्ड फोर्स लगा करके रखूं? व्हाट इज क्यू? All these questions fall under the same category, and this is a very common type of question. Inclined rod placed on a wall and floor. कभी धागा बांध देते हैं, कभी फ्रिक्शन ले आते हैं, कभी नीचे फोर्स लगा देंगे, कभी ऊपर फोर्स लगा देंगे, मतलब इक्विलिब्रियम में लेकर के आ जाएंगे. Eventually they will give you a problem of equilibrium and ask you to find either the unknown upward force or the unknown horizontal force or the unknown tension, all these things. तो इस टाइप की प्रॉब्लम्स भाभी कट्टी में एक आध सॉल्व हैं, एंड आई विल गाइड यू टू द प्रॉब्लम्स सो दैट यू कैन प्रैक्टिस देम ऑन योर ओन. सॉल्व एग्जांपल्स हैं तो आपको उसके स्टेप्स भी दिख जाएंगे, आंसर्स भी मिल जाएंगे, so you can practice these questions. And now there is yet another type of question that can be commonly asked in the examination, and since we are short of time here, तो अब ये वाली
सर
जो ये जो प्रॉब्लम है इसको अपन नेक्स्ट क्लास में डिस्कस कर लेंगे, and after that we will move on to the next topic. So if anybody has any doubts regarding what we have studied today, please ask me.
सर
हाँ,
सर वो पॉइंट सी को है ना स्टेशनरी पॉइंट क्यों नहीं लिया सर?
पॉइंट सॉरी हियर, हाँ कौन से पॉइंट की बात कर रहे हैं अपन?
पॉइंट सी।
पॉइंट सी तो देखो दीवार से फिक्स है,
हाँ सर,
तो वो तो मूव ही नहीं कर सकता।
तो सर उसे स्टेशनरी पॉइंट नहीं ले सकते?
उसको भी ले सकते हो, यस डेफिनेटली यू कैन टेक सी एज द स्टेशनरी पॉइंट, नो डाउट। आप उसको लेके करोगे तो आपकी इक्वेशंस में थोड़ा सा डिफरेंस आ जाएगा, थोड़ा सा चेंज आएगा, लेकिन ये जो फाइनल एक्सप्रेशन है, जो आपका आंसर है, दैट विल रिमेन द सेम, दिस आंसर विल रिमेन द सेम। दैट इज अ वेरी गुड क्वेश्चन आस्क्ड बाय यू, बाय जिन जो बाकी लोग सुन रहे हैं वो एक बार समझें कि इन्होंने क्या क्वेश्चन पूछा है। He has asked, since point C is also stationary and it is not moving, can I select this point as origin? You can definitely select this point as origin. There is no problem with that. आप इसको करके देखो, this is a very interesting situation. I suggest that you try by taking this point as origin and redeveloping all the equations as I have made you understand today. आज जैसा मैंने आपको सिखाया वैसे मैंने इसको ओरिजिन लिया था, आप इसको लेने की बजाय इसको ओरिजिन लेके करके देखिए, सेम आंसर आना चाहिए आपका, देयर शुड बी नो डिफरेंस। स्टेप्स में थोड़ा सा चेंज आ जाएगा, आपकी इक्वेशंस में थोड़ा सा चेंज आ जाएगा, जो मैंने डेवलप किए हैं वो इक्वेशंस नहीं आएगी, लेकिन इवेंचुअली जो टेंशन की वैल्यू मिलेगी वो यही आएगी, यू विल गेट इट। ठीक है, एनी अदर क्वेश्चंस?
सर वो क्वेश्चन रिपीट कर देना वापस, वो टेंशन और एमजी एक्टिव फोर्स।
टेंशन देखो, यहां से धागा बांध रखा है तो टेंशन इसको रॉड को अंदर की तरफ खींच के रखेगी, और रॉड का जो सेंटर है, ज्योमेट्रिक सेंटर है, उस पॉइंट पे रॉड का वेट एक्ट करेगा mg। क्या यही पूछ रहे थे आप?
यस सर।
क्लियर हो गया?
सर क्यों लेते, लेकिन मतलब रीजन क्या है?
किसका रीजन पूछ रहे हैं आप?
सर एमजी और टेंशन लेने एक्टिव फोर्स का।
क्योंकि आपके सिस्टम में और कौन सी फोर्सेस हैं जो इक्विलिब्रियम मेंटेन कर रही हैं? एक रिएक्शन है,
यस सर।
एक दीवार से और जमीन से रिएक्शन है, लेकिन चूंकि जमीन ऊपर चढ़ नहीं सकती, दीवार आगे पीछे हो नहीं सकती, तो इनके कारण वर्चुअल वर्क होगा ही नहीं, तो इसको हटा दो, इसको हटा दो। लेकिन ये जो दो फोर्सेस हैं, टेंशन और mg, ये जहां पर लग रही हैं, mg इधर लग रहा है, टेंशन इधर लग रहा है, ये दोनों पॉइंट्स आपके रॉड के मोशन के साथ ऊपर नीचे मूव कर सकती हैं, और चूंकि इनका मोशन हो सकता है इसीलिए इनको एक्टिव फोर्स की तरह से ट्रीट किया जाता है, और आपकी प्रॉब्लम में सिर्फ यही दोनों आएंगी, क्योंकि यही दो फोर्सेस हैं जो वर्क कर सकती हैं।
यस सर। ओके सर।
Okay, now let us take attendance. Please don't go away. मैं 2 मिनट और लूंगा जिसमें मैं आपके अटेंडेंसेस आपको एक बार बोल के भी सुनाऊंगा। Let me stop the recording first.